Good day! Today, we will tackle the divergence of vector field. First thing to note is the definition of divergence. Divergence is defined as a vector operator that operates on a vector field, producing a scalar field giving the quantity of the vector field source at each point. Let us also remember that divergence computes a scalar quantity from a vector field by differentiation.
In terms of mathematical operations, there are formulas that we must discuss. So, for an instance, if a of xyz is a vector function of position in 3 dimensions, that is, a is equal to a sub 1 I hat plus a sub 2 j hat plus a sub 3 k hat. Then its divergence at any point is defined in Cartesian coordinates by divergence of A is equal to the partial derivative of A sub 1 with respect to x plus the partial derivative of A sub 2 with respect to y plus the partial derivative of A sub 3 with respect to z. We can write this formula in a more simplified notation using a scalar product with the inverted triangle or the vector differential operator. So let us rewrite this equation. The equation will be divergence of A is equal to the quantity of I hat with partial derivative with respect to x plus j hat partial derivative with respect to y plus k hat with partial derivative with respect to z times your function of A. So simplifying this equation, the divergence of A will be equal to the dot product of the vector differential operator, which is symbolized by an inverted triangle, times the vector A. Notice that the divergence of a vector field is a scalar field. Furthermore, we can understand this by having some examples. And for our first example, let us compute the divergence of vector f, which vector f is equal to x squared y, xyz, and negative x squared y squared. First step is to substitute these components into our equation. The divergence of f will be equal to the partial derivative with respect to x times the first component x squared y plus the partial derivative with respect to y times the second component plus the partial derivative with respect to z times the third component x squared y squared. So next, let us get the partial derivatives of each component. So the partial derivative of x squared y with respect to x will be equal to 2xy. And the partial derivative of xyz with respect to y is equal to xz. And lastly, the partial derivative of negative x squared y squared with respect to z will be equal to 0. So simplifying, we have the divergence of vector f will be equal to 2xy plus xz. That will be our final answer.
So today I will be discussing another example. In our example number 2, our vector field is equals to x squared minus 3x plus 2i plus y squared minus 3y plus 2j. Solving for the divergence of our vector field is equals to the partial derivative of our x component with respect to x times x squared minus 3x plus 2 plus the partial derivative of our y component with respect to y times y squared minus 3y plus 2. So, the divergence of our vector field is equals to the partial derivative of our x component is 2x minus 3 plus the partial derivative of our y component, which is 2y minus 3. Simplifying our divergence of our vector field will be equals to 2x plus 2y minus 6. So, we have solved the divergence of our vector field.